One of the subjects that you had to do an interactive physiology program for was called cardiac output. In other words, what's the volume of blood that each ventricle squeezes out in 1 minute? So our formula for that was cardiac output. It was basically heart rate, which is, the beats per minute, times something called stroke volume. All right, so what we're going to look at here on this particular picture is what is stroke volume and how would we figure out stroke volume. So what we need to look at here is, let's go ahead and start at A and describe what's going on here, and that will hopefully help us figure out stroke volume, which is part of the equation for figuring out cardiac output. Now notice, first of all, we talked about in the last video that I did, what diastole meant, and it meant relaxation. So in ventricular diastole, that's basically what's going on with the ventricles relaxed, and we know that about 70% of blood going from the atria to the ventricles occurred passively without any squeezing, and then the last 30% was squeezed down into the ventricles. So notice here we've got blood going from atria to ventricles, both, and that would actually be both passive and active, both atrial diastole and systole. Okay, but here in our example, then what we're doing here is we're showing fluid going into this pump. So as the pump is filling up, that's the same thing as our heart being a pump filling up with blood. Okay, now at the end of the ventricles going through their relaxation period, when they are full with as much fluid, in the case of the heart, of course, the fluid would be blood, but in this pump, whatever the fluid is, notice it's coming in here, and at this point, it's as full with as much fluid that's going to go in this pump. So now at this point, at what we're going to call end diastolic, end of relaxation volume, then this is however much blood was able to get into each ventricle. All right, now, systole, we learned, means contraction. So the purpose of systole or contraction is to actually push the blood out of the ventricles. Okay, so ventricular systole, we're going to push the blood out of the ventricles. So the amount of blood that we actually do push out is what's going to end up being our stroke volume, and that's the volume we have to know for our cardiac output problems. So how do we come up with that number? Well, remember, when we squeeze blood out, then we don't squeeze every drop, every milliliter of blood out, but instead some of it stays behind. So what actually stays behind and is not pumped out, we call our end systolic volume. At the end of our contraction, how much blood was left? How much blood did not get pumped out? So how we do this in our cardiac output problems is, if you're not given stroke volume, a lot of times what you'll be given is you'll be given an amount for end diastolic volume, the amount we could get in here, and then we have an amount that was left over. So in order to find stroke volume, what we have to do is take the end diastolic volume, the bigger amount, subtract what was left over, and then that tells us how much left, and that gives us stroke volume. So again, make sure you do the program on cardiac output, and they'll actually ask you to do a couple of cardiac output problems. But what we want to look at here is, what is stroke volume? And it is the amount of blood that's pumped out. But how's that relationship fit with these other two terms, end diastolic volume, end systolic volume? So think end diastolic, at the end of relaxation, before I squeeze any out, how much do I have? And then at the end of systole, after I've squeezed out, how much do I have left? So if I want to find this, I subtract this amount from that amount, and that tells me how much I actually squeezed out.